Welcome back to the Solutions Manual. In this video, we will solve the problem 2.12 from Alexander and Sadiku, Fundamentals of Electric Circuits, 5th edition. According to this problem, in the circuit in figure 2.76, in this figure, we have to obtain V1, V2 and V3. So to solve this problem, we will use the Kirchhoff's voltage law, also known as KVL in short. But before that, we have to consider the sign convention that we will use in this problem. So this sign convention is for cells or batteries. So if the direction of loop is from the positive to the negative terminal, then the potential difference will be considered as negative across that cell or battery. And if the direction of loop is from the negative to the positive terminal of the cell or battery, then the potential difference across will be taken as positive. I believe that you are familiar with this term of loop. Loop is the any closed path in a circuit. So these are my loops. This is the loop L1. This is the loop L2. And this is the loop L3. I have considered all of the three loops as clockwise. But if you want to, you can consider them as counterclockwise as well. They would still give you the same answer. So starting from loop 1, we will apply the KVL, that is algebraic sum of all the potential differences in a closed loop is 0. I want you to analyze the movement of loop L1. The loop L1 is moving in the clockwise direction. So as it is moving from the 40 volts, it is moving from the negative to the positive terminal. So according to the sign convention, if the direction of the loop is from the negative to the positive terminal, the potential difference will be taken as positive. So this is positive 40. The direction of the loop is from the negative to the positive terminal across this 50 volts. So this 50 volts will be taken as positive as well because of the sign convention. Now, here the loop is moving from the positive to the negative terminal. So according to the sign convention, these 20 volts will be taken as negative. And across the V1, the loop is moving from the positive to the negative terminal. So V1 would also be taken as negative, equals to 0. So upon simplification, V1 comes out to be 70 volts. So this is our first answer. Now for V2, we have to consider the loop 2. So applying the KVL, we have algebraic sum of potential differences in a closed loop is 0. I want you to consider the movement of loop L2. As the loop is moving in the clockwise direction, it is moving from the negative to the positive terminal. So these 20 volts, according to the sign convention, will be taken as positive. Across these 30 volts, the loop is moving from the positive to the negative terminal. So according to the sign convention, these 30 volts will be considered as negative. And across this V2, the direction of the loop is from the negative to the positive terminal. So this V2 will be taken as positive. So V2 equals to 0. So upon simplification, V2 comes out to be 10 volts. And this is our second answer. Now we have to find the voltage V3. For that, we have to consider the loop L3. So loop 3. Again applying the KVL. So algebraic sum of all the potential differences in a closed loop is 0. Again, you have to analyze the movement of the loop L3, which is moving in the clockwise direction. So as it is moving in the clockwise direction, across V1 it is moving from the negative to the positive terminal. So V1 according to the sign convention will be taken as positive. Across V2 it is moving from the positive to the negative terminal. So according to the sign convention, V2 will be taken as negative. And across V3 it is moving from the positive to the negative terminal. So V3 is also negative, equals to 0. So V3 is basically the difference between V1 and V2. So V3 is equals to V1 minus V2. V1 is 70, V2 is 10. So V3 comes out to be 60 volts. And this is our third answer. So this is it for this problem. I hope you would find this video helpful. If you do, please make sure to subscribe to this channel and also turn on the bell icon for the daily updates. And if you have any questions or any doubts in the KVL or in the KCL, then feel free to ask in the comment section and I will try to answer them as soon as possible. Thank you.